Inveno Engineering, LLC, we are global leaders in steam system engineering, recognized for our unmatched steam system expertise and dedication. Unlike many self-proclaimed steam system engineering firms, we focus solely on delivering innovative engineering solutions, never products. Our commitment is to steam system engineering excellence, not salesmanship. Today, we'd like to give you a brief introduction to industrial steam systems. In today's industrial steam systems, there's top 5 things that we look at in the steam system. Safety number 1, of course. Reliability number 2. Optimization number 3. Energy number 4. Emissions number 5. Steam system safety. Knowing the codes ASME, B31.1, B31.3, or the ASME pressure vessel codes. We also have the ASME boiler codes, just to name a few. To ensure a safe steam system, we need to know these codes. Example, heat exchanger. ASME data plate reads 150 PSI, 338 degrees Fahrenheit. Is this unit able to operate on a 100 PSI steam system? The answer is no, because 150 PSIG is 366 degrees Fahrenheit, not 338 degrees Fahrenheit. Therefore, it is not a pressure vessel because of the ASME stamp is incorrect. A steam valve is rated for 600 PSIG. Can this valve be used in 175 PSI steam system? The answer is no. 600 PSI CWP, cold working pressure, it means 600 PSI at 70 degrees Fahrenheit. When you start to adjust for the steam temperature at 175 PSI, the pressure rating will decrease as the steam temperature increases. Therefore, you need to know the maximum steam pressure and the maximum temperature for every component that is installed in the steam system. Reliability when purchasing a product, boiler, valve, heat exchanger, etc. How long do you want the component to last? 1 year? 3, 5, 15, 30 years? If you want it to last 15 years, you will pay more money for the component. A 1-year operational component has a lower price than the 15 years. Therefore, if you want reliability in the steam system, then pay for it. There are components that are designed to operate for 1 year or the typical warranty period. There are steam valves that are warranted for life. You will pay much more for that steam valve than a valve that has 1-year warranty. 250 PSI steam pressures or less, all products and components need to operate and perform for 15 years without failure. We cannot accept premature failures in today's steam system. There's no reason that a component cannot last for 15 years with today's technology. Again, today's steam operation, we cannot afford premature failure. Part of any program to get reliability, you must do root cause analysis, which is not too difficult. When a component fails, remove the component and take it apart to look at the component. Example would be here. This is a casting failure or corrosion in the pipe and an internal steam valve failure. If you do not do root cause analysis and take a failed component out and put the same type of component back in the steam system without understanding failure, it will fail again. Root cause analysis is a must to get reliability. Optimization. First step in optimization in any steam system is having a steam balance. Know where the steam is going, who's consuming the steam, and how we're getting the condensate back to the boiler plant. The plant needs to understand the steam system thermal cycle efficiency. Without a steam balance, it's very difficult or impossible to determine the steam system thermal cycle efficiency. Emissions. The steam vent is venting 10,000 pounds per hour of steam, equals to the following: 12,659,585 pounds of CO2, 10,200 pounds of NOx, 102,300 pounds of SO2. The plant wants to be green, then optimize the steam system. It's in direct relationship to reducing emissions. The one thing that the plant must do is change what we're doing in the steam system. What we did 5 years ago in steam systems is not what we do today. Change must occur. Results does not equal no results plus a good story. Without change, no improvements are achieved. Example here, you cannot vent steam to atmosphere. It's a #1 major loss of energy in a steam system. Plants around the world quit venting steam to atmospheres 20 years ago. Steam is used in all types of industries. To make almost all products, we need steam in some facet. Steam distribution systems, largest steam grid in the United States is New York City. We also have steam grids in Milwaukee, Minneapolis, and the list goes on. We also have major universities which have large steam grids. Why? Because we can transport tremendous amounts of energy long distances without the need of a pump to pump the vapor. Electric generation, steam is still the largest motivator for the turbine. That's not going to change. Rubber products. We have plants that produce 60,000 tires a day. You could not do that without steam. Pulp and paper production, huge amount of utility costs in the pulp, and paper production is used for steam. Food processing, all types of things we use in the food processing industry. Sterilizing yogurt cups, puffing cereal, deodorizing cocoa butter, and the list goes on. Pharmaceutical, we have a specific steam, clean steam for the pharmaceutical plants. Fuel production, a refinery can have 30 to 40,000 steam traps. We use steam for everything. And same thing with chemical products, reactors, and the list goes on. The steam system efficiency. To improve efficiency, reliability, reduce downtime, increase production, and reduce energy, it's necessary to evaluate and understand each component of the system. It is a system. Understand all components in the system. A boiler with a deaerator operation, then steam out to the end users, and of course a condensate return system. Evaluate all components. Example is here is understanding the different pressures in a simple process. Things the plant needs to know: the inlet pressure, pressure after the control valve, pressure dropping in the heat exchanger, inlet pressure of the steam trap, outlet pressure. Get your differential pressure so you can size the steam trap properly and understand the condensate line pressure. You need to understand all the dynamics of the steam system. The steam system, boilers, piping, valves, expansion, end users, heat transfer tracing, steam traps, list goes on. And the condensate return system, pumps, condensate line sizing. We often ask a simple question: what happens on Monday? The answer should be change. Without change, there can be no improvement, whether in safety, efficiency, or reliability. At Inveno Engineering, LLC, we are global experts in steam system engineering, dedicated to helping facilities worldwide achieve excellence. For more information, please visit our website or contact us directly with any questions about your steam system needs. Thank you for your time and interest. We look forward to helping you improve your steam system performance.